Hey guys, in this video we're going to take a look into an introduction into circles, and with this lesson we're just going to take a look at the vocabulary and worry about identifying parts of the circle. So to start off with, a circle is a set of points that are the same distance from a given point, and that given point is the center. So this part right there, that's going to be our circle. The center of the circle is the point that's in the middle, and it's going to be used to name the circle. So for example, this circle up here is circle P. Also part of a circle, you can have a diameter. A diameter is a line segment that passes through the center of a circle, and it's equal to 2 times the radius. And whenever you name it just like a segment. So looking at this one, the diameter of this one is going to be line segment AB. And then again, they could ask you to calculate the diameter. Diameter is equal to 2 times the radius. And the diameter goes from that point through the center to that point. Now, ideally, whenever they show you a picture and ask you to identify the diameter, ideally they will show you the center of the circle, whatever point that is. Sometimes they won't, and you just got to go kind of, I guess, eyeball it. That's not the best way to do it. But if they don't give you a center and they show you a line of pictures and they say which one's the diameter, and they don't show you a line segment that goes through the center, pick one that is the closest. But technically, if they're going to do a diameter, they should have the center through that segment. Okay. Next, looking at radius. Radius is a line segment that goes from one edge of the circle, so in this case point C, to the center. The radius is equal to half the diameter, and when you name a radius, it's named just like a segment because that's what it is. So this one would be radius CP, and just in case they ask you to calculate it, radius is equal to half the diameter, or another way to write that is your diameter divided by 2. You could also have things called chords. A chord is a line segment that goes from one side of the circle to another, and it's named just like a segment because that's what it is. So in this one, this is chord DE. And if you notice in the definition that I gave you for a diameter, I put in parentheses a chord. A diameter is a type of chord. It's a very specific one where it has to go through the center. And if all the other segments that would go through a circle that didn't go through a center, those are just called chords. You can also have central angles. A central angle is an angle in a circle that has a vertex on the center and endpoints on the circle, and it is named just like a regular angle. So looking at this one, in order to have a central angle, the vertex of your angle has to be in the center. That's why it's called a central angle. Okay, so there's the vertex on the center, and then endpoints on the circle. And it doesn't have to end. It can technically keep going on forever, but it at least has to have points on the circle. So if we were going to name this would be called angle BAC, or you could also name this angle CAB. It's still following those rules of naming an angle where the vertex has to be in the middle. And this right here, that's going to be our central angle right there. Looking at the next one, it's an inscribed angle. And the way you have an inscribed angle is an angle that has the vertex on the circle, so there's its vertex on the circle right there, and endpoints on the circle, and it's still named just like a regular angle. So this one would be named angle APB or angle BPA. And again, this is an inscribed angle because it's got a point on the circle. And it doesn't matter where it is. It could be up here with these endpoints, it could be all the way down there. You can move the endpoints wherever you want. Just the big thing is central, the vertex has to be on the outside, and it's got to touch that circle. Central angle has to be on the center. Anywhere in between is something we're not working with yet. Okay. Next, we're looking at an arc. An arc is a part of the circumference of the circle or just part of the circle itself. So if we're looking at this picture here, there's lots of different arcs that we have on there. So the first one that most people would probably find would be that one right there. And that's called arc BC. You could also write that with a curved line above to make it be an arc. So that's kind of the notation right there. That means arc. But that's not our only arc that we have on there. We also have an arc DB or BD, it doesn't matter. I'll put them alphabetical. So it's a part of a circle that goes from one point to another. All right, those aren't the other ones, or those aren't the only ones. We've also have an arc that goes from D to C, so we could call that arc DC. So those are the littler arcs that we have on there, or our minor arcs. A minor arc is an arc in a circle that is less than 180 degrees, and it's named by the two endpoints on the arc and the point in the middle, if there is one. No. I forgot to take that off. So a minor arc is an arc in the circle that is less than 180, and it's named by the two endpoints on the arc. So if we're using this picture that we had up here, and I'll put it on here so we've got it to use. All those right there are the minor arcs for this circle. They're all less than 180 degrees. And a good way to tell whether or not you have an arc is to take something with a straight edge and connect one of the end points of your arc with your center, and then if it's less than, like if you can still see that other point, that's how you know for sure that you have a minor arc. If it's going to be right there, that's going to be a semicircle. We'll get to that in a minute, but here's your minor. That's how you figure out whether or not you have a minor arc. So there you can see all of the blue, so you know that blue is a minor arc. Looking at that green, that's not even close, so we won't worry about that one. And then there's the center. I'm looking at the yellow one. There's the center, there's an end point, and you can see all of the portion of that yellow for that minor arc, so you know for sure those are all less than 180. So all of those are minor arcs. So we could go arc DB is a minor arc, arc BC is a minor arc, and arc DC is also a minor arc. Well, if we're going to classify something as it being less than 180 degrees, we can classify something as being more than 180 degrees. And that would be a major arc. And that's going to be named by the two endpoints on the arc, and I think I got these definitions switched. And if there is one, a point in the middle. Okay, so if we're looking at this one and we're looking for a major arc, it's got to be more than 180 degrees. So if I'm starting at B and I'm looking for a major arc, I can't stop at D because we've already tested that that's less than 180. So to make it be a major arc, we would have to go all the way to C. That's greater than 180 degrees. So the way we would name that major arc is to call it, and when you're naming these major arcs, it's kind of like you're naming an angle. So you've got to make sure that whatever point is in the middle is in between of the two outsides. So we could name this one arc BDC, or we could name that arc CDB. It doesn't matter, whichever, just as long as that D is in the middle. And that tells people that whenever you're looking at this arc, you're going to start at B, you're going to go through D and all the way to C. If you put D anywhere else, they're going to start at D and then go other places, and that's not what would want to happen. So let's say they started with D, and then wrote it like that. So if they had said arc DBC, it would be that arc right there. You could also name that arc CBD. And there's one more on there. If you had started with D, C, and then went to B, that would be another arc. So we could have arc DCB, or we could name that arc BCD. So those are the three different major arcs that you have on there. So there's your, so there, all of those are different types of arc, the major arc and the minor arcs. The other one that I started talking about and then waited was the semicircle. A semicircle is an arc that is equal to 180 degrees, and it's named by the two endpoints on the arc. So I'm going to label this one FG. And again, hopefully they would give you the center of the circle, and then you could use your ruler to double check and make sure that really was the center. I'm going to stick with circle P. And the way you would name this arc is you would just name it FG. There's no special notation for it being a semicircle. You would just look at it and know it's 180 degrees. Or they would tell you it's a semicircle. Okay. You could also have the secant of a circle. A secant of a circle is a line or a line segment that goes through a circle at 2 points. And this is the key part. It goes through the circle. It's not a chord. A secant is not a chord. It's going to go all the way through both points. So we could call this one line AB or line BA. You couldn't call it a line segment because it ends at those points, and the secant has to go through 2 points. Tangent, and I mean, that's the big part of the definition. Through a circle, 2 points. Looking at a tangent is a line or a line segment that touches a circle at 1 point. So this tangent would be called, you would probably call it line L. That's a cursive L because you don't have the 2 points to name the line, so it would just be called line L. And then the point of tangency, it's going to be where that tangent line touches the circle, and it's only going to ever touch at that 1 point. And the last vocabulary word that we have of things that we can work with is a sector. A sector is an area of a disc that is on the inside of a central angle. And you notice I have disc there with circle in parentheses. Most of the time, whenever people look at a shape like this, they're going to tell you, well, that whole thing is just a circle. And if you want to get technical with it, this right here, that is a circle. So that's technically a circle. Remember, it's all the points that are equidistant from a central point. When you're looking at the area inside, so the circle is like circumference. Circle is like circumference. When you're looking at area inside, the parts on the inside, that's going to be what is technically called a disc. So all that space on the inside, that is a disc. So while most people will think of it as a circle, it's technically not, and that's the difference between them. Anyways, sector. It's the area of a disc that is on the inside of a central angle. So pretty much, you've got a central angle, you've got one radius there, you've got another radius there. They're going to have the same exact length. You're going to have an arc, and you're looking at all of the area that's on the inside. And there is a way to calculate that. We'll get to it later. Right now, all that we're really worried about is being able to look at a picture and either name or identify what part of the picture that it's showing you. If you have any questions, be sure to write them down and ask whenever you get to class.